Oh my goodness. The videos are back. Some of you are shrieking with joy, and some of you are sighing a big, horrific sigh right now. Nonetheless, here they are. So, Darwin and the history to his theory of natural selection. We're talking evolution. All right, the man, the myth, Charles Darwin. On November 24th, 1859, Darwin published a book on the origin of species by means of natural selection. And this book deals with the biodiversity that's seen in the earth. It has three main themes. The three themes, the similarities and differences that exist among species. So how are they similar and different? Adaptations that evolved in species in order to survive in an environment, and the geographic distribution of species around the world. I love this stuff. I just eat it up. I love looking at correlations. All right. Um, so the ancestry and common ancestors among species are discussed throughout the book, thus helping support Darwin's theory of natural selection. Natural selection being and competition, those two are major driving forces to the evolution of a species over time. So how does it change over time? Well, natural selection and competition are the largest factors. Nature is going to decide what species are able to survive and reproduce. Remember, guys, if you get anything, get that. It's all about surviving and reproducing. If we can't, if we just survive and we don't reproduce, then our genetic material does not pass on. So, those with favorable traits for that environment survive and reproduce, and those with unfavorable traits survive to reproduce, struggle to survive, and rarely reproduce. Okay, so this is every species. Why do some male cardinals get to reproduce? Because they have the right colors, or they know the right song, or they know how to flap the right way. And the women think they're great, and so they're going to reproduce with them. The male that can't do those things or doesn't look the right way, well, he's probably not going to get to reproduce. Over time, because of this struggle, the weaker species eventually goes extinct. He's not reproducing, or she's not reproducing. So whatever traits that they have that are not favorable are not getting passed along. So we say that species, or possibly what could happen is that species then migrates to a different or more favorable environment. I mean, think about it. Um, I had a friend that brought her son. She taught here, and brought her son to school here, and he was very popular in other school. Handsome kid, played sports, athletic, fun, really fun. Came here and just didn't fit in at Trussville. It was not the favorable environment for him. Not that he was reproducing, mind you, but he he just had a hard time here, and so he ended up going back to the school that he originally was at. And so they can migrate to a different place if that's even a possibility. All right. So let's look at Darwin's predecessors. Who came before him, and who did he learn from? Plato. Plato was 427 BC to 347 BC, and he came up with the first attempted organization of nature. We try to think of patterns. He came up with the first one, and he believed that there were two different worlds that existed based on the gods of Olympus and Earth. So there was the world of the gods, where everything was real and perfect, and then there was Earth, where we see birth defects, and the everything is illusory. Okay, I can't even say the word, illusory and imperfect. Then we look at Aristotle, 384 BC to 322 BC. Now, he was a student of Plato's, and he worked with Plato's model a little bit here, and he developed the Scala Naturae, which means the scale of nature. And Aristotle believed that each species had its own rung on the ladder of life. So getting a little more detailed for sure. And that this species' position is permanent and perfect. So man is at the top, just below the gods, but that everything occupies a rung on the ladder. Now we move into old Carolus Linnaeus. Carolus, I mean, really? Was that like a popular name then? What were you thinking, Carolus? I'm going to name my son Carolus. All right. So you can see big gap from 384 to 322 BC with Aristotle to 1707 to 1778 AD. So a lot of time elapsed. We call Carolus Linnaeus the father of modern taxonomy. Taxonomy is the science of species classification. So we classify things. There were originally only two kingdoms that he came up with, plant and animal, Plantae and Animalia. His system uses what we call the binomial nomenclature. And of course we know bi means two, nom is name. So binomial nomenclature is a two-name naming system. So the two-name naming system here, and the rules of it are here's how it's written. It's written in italics, and the genus name, the first letter is capitalized, and in the species name, it's lowercase. So you can see here, Homo sapiens, that's us. So here's the common name, here's the scientific name for humans, Homo sapiens. That's the genus, that's the species. You can tell immediately that it's the species because it's lowercase. Everything else is going to be uppercase. All right. Now, also we use Latin in naming because Latin is considered a dead language. That means it's not going to change. You think about our language and how much our language has changed over the years and terms. I mean, just think bad. You know, I mean, bad used to mean bad, like it was yucky. And then bad meant, whoa, that's so bad. It meant good. I mean, yeah, I'm telling you, over the years, I can hardly ever keep up with the lingo because, you know, my language doesn't really change, but then I hear stuff from kids all the time. So we'll have to explore that a little bit. That would be fun. All right. The taxonomy, so the current levels, what we call the taxons of classification. We have domain, kingdom, phylum, class, order, family, genus, species. And the largest being the domain, and then we break it down all the way down to the most specific information coming from the species. That's where we get the name species, because we're the most specific. It's the specific epithet. And so this tells us exactly. If I said I'm thinking of something in the kingdom Animalia, you don't know what I'm talking about. But if I say Canis lupus, well, everyone knows we're talking about the gray wolf. All right. So an easy way, now they give in the notes, he gives an easy way of remember that it would be dominating King Philip came over for green salad. Whatever. Is he promoting health? Now, before we used domain all the time, I just said King Philip came over for great spaghetti because I'm Italian. I guess I should say, duh, King Philip came over for great spaghetti because I'm Italian, so you would think I'd have great spaghetti. Whatever. All right. George Cuvier, 1769 to 1832. So he was a famous paleontologist. This is the person who studies fossils. Paleo means old, and onto means bones. So old bones. And what he found is that he looked at fossils, and fossils are mainly found in sedimentary rock. Some are found in plant sap, so you'll see that. You can actually have preserved, like in the movie Jurassic Park, there was in amber, there was things preserved. Sedimentary rock is mostly formed by being at the bottom of a body of water, like at a swamp, a lake, something like that, where there's going to be a lot of pressure. When organisms die, they settle to the bottom, they get covered up by the eroded earth, and then over time, because that pressure and that weight of the sediment creates so much pressure, um, and the uh, and the water preserves the organism in this fossilized state. So without the body of water and sediment in the water, it's very hard to have the process of fossilization occur. And that's why we don't have fossils for every species that's occurred over the earth. Or possibly. I mean, who knows why we don't have fossils for everything. Although some are still hidden in the dirt. What we do know is we have to have water, pressure, and lots of time to create fossils. So the term strata means layer. And we can tell the age of rocks and fossils based on the location of the strata, or we can assume we can. So we look here, the oldest layers are on the bottom, the youngest layers are on the top. That makes sense. When I make a lasagna, my first layer is the one I put in first. The one at the top is going to be the last layer that I put in there. And so what Cuvier proposed is his theory of catastrophism. This theory tries to explain why organisms seem to suddenly disappear from their existence on Earth, such as the extinction of the dinosaurs. Some catastrophic event must have occurred to cause their sudden, in geologic terms, extinction to occur. So suddenly they're now gone, and there has to be some reason for that. Now, Jean-Baptiste Lamarck, whoops, he's gone, 1744 to 1829. He proposed a theory of evolution in 1809. That was the year Darwin was born. And it turns out to be only partially correct. And what he talked about, his theory talked about the inheritance of acquired characteristics by means of use versus disuse. And that became known as Lamarckian evolution. And it basically states that if an organism uses a body part routinely, it becomes of importance, and therefore the body part's going to be passed on to the next generation. Well, you know, this party got wrong. If it was true, think about bodybuilders. They're massive muscles. You know, if they're using them, then they get passed along, and their children will all have massive muscles too. But that is not the case. Or you could think about it in terms of if someone lost a leg, well, then it's not being used. So when they had children, their children would be born without a leg. Obviously, that's not the case. That's not what happened. Now, Lamarck's theory also makes no mention of the environment's role in evolution in these changes. And so he was wrong there. But, you know, he kept pushing forward, certainly kept the concept moving along forward. Oh, it would be so sad, but that's the end of our first video.